Okay, so now that we have reviewed inverse functions, we'll be able to take a look at some more advanced ones. So depending on what kinds of problems we're solving, we might be asked to invert the sine function, or invert the cosine function, or invert the tangent function, and so on. Now, one thing to be mindful of is that all of those functions I've mentioned fail the horizontal line test. None of the trig functions are one-to-one, exactly because every single trig function is periodic. They repeat their same values over and over again, infinitely. Now, that's not going to stop us from being able to reverse one of these functions, but the trick is, well, what do we mean by inverse? So here I'll have y equals the cosine of x. And just like we saw yesterday, if I write x equals cosine of y, then this curve in blue is not a function. The solution to this problem is to say, well, I only really care about principal solutions, right? So if I'm taking the cosine of some variable x, that's only really defined up to how many times I've wrapped around the circle. I can't really tell the difference between pi radians and 3 pi radians. They're the same point on the circle. I've just wrapped around more or fewer times. So I would like an inverse trig function that only tells me an angle measure between, well, maybe 0 and 2 pi, maybe pi and negative pi, depending on what exactly the trig function I'm inverting is. And so we call these the inverse trig functions. Here is the arc cosine function. So it is convenient that the arc cosine function only takes values between 0 and 1. Excuse me. The cosine function itself only takes values between 0 and 1. No. Stop this madness.